Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class we have completed the chapter on machine. Today we will be starting a new chapter. It is about refraction of light. So without much wasting time, let us quickly move on to our topic. So note down the topic for today: refraction of light. Okay. So all of you have read about reflection to some extent in class 9, I think so, and considering that you have already a brief idea about reflection, we will be moving on to the chapter called refraction. So today we will be starting about refraction of light. So refraction of light. Rather, you can say that this chapter is mainly concentrated at refraction at plane surfaces. Refraction at plane surfaces. Okay. So first of all, let us understand what refraction is and also what is the cause for refraction. To understand this, or before jumping on to the topic refraction, just let me briefly recapitulate the concept of reflection. I think you have remembered, all of you have remembered the concept, but for a bit of memory refreshing, let us just talk about reflection. I think you have known that reflection was actually the bouncing back of light. Something termed like bouncing back of light was being used. Actually, what it means that when light is coming from a certain medium and it falls on a, say, an opaque object, and that opaque object is, it can be either highly polished or it may not be polished, that doesn't matter. But when light coming from a certain medium falls on that opaque object, what happens? The light hits that opaque object and moves back into the same medium from which it was coming. So this is the main concept about refraction. Reflection. Okay. So in reflection there were two laws, if you have remembered. One law is that the incident ray, reflected ray, and normal at the point of incidence all lie in the same plane, and the second law was that the angle of incidence is always equal to the angle of reflection. So these are the concepts of reflection. Now what is refraction then? See, when light travels from one transparent medium to another transparent medium, it is not falling at the surface of any opaque medium, rather it is just passing from one transparent medium to another transparent medium. Then can you imagine or understand what will happen? Obviously, as both the mediums are transparent, the light will pass through, but there is one problem. What is that problem? You know that light have a maximum speed of what is the value? Do you know? Maximum speed of 3 into 10 to the power 8 meter per second, and this speed is obtained in which medium? I think if you remember, this is obtained either in vacuum or we can also say in air, isn't it? Either in vacuum or in air. Fine. So this is the maximum speed. But do you know that light, when enters any other medium, what happens? It slows down. In any other medium, light does not travel with this speed. It slows down, and it will definitely move at a speed quite lower than this speed. So when light travels from one transparent medium to another transparent medium, as the speed of the light changes, either increases or decreases, but it will not be more than this value, the path of the light will change. That is, the path along which the light was traveling, the light will get deviated or bent away from that path. Basically, this concept or this phenomenon that is happening can be regarded as refraction. So just before giving you the definition of refraction, let me demonstrate you two cases with the help of the ray diagram. Okay, remember this thing, that refraction is caused due to the change in speed of light. Okay, later on we will be just again recapitulating that fact. So now let us come to two figures. Let us consider two cases, and we will be discussing these two cases using some ray diagram. Consider that light is traveling from a denser to rarer medium, or say first of all consider from a rarer to denser medium. So this is the surface separating two medium. Now light is coming from, I can say light is coming from a rarer to denser medium. So let us consider that light is coming in this fashion. It falls on here. Okay, it had the light been traveling through the same medium, it would have definitely traveled in this direction. But what happens here, actually this surface, this side is say it is air. Now air is a rarer medium in comparison to say this surface is water. Okay, water. Now water is a denser medium in comparison to air. Remember this thing. In comparison to air, it is a denser medium. Right? Now, when this happens, that light is moving from this air to water, what happens? The speed slows down, isn't it? Because water is much denser medium, so speed of the light is less in water. Now, if I consider that I draw a normal at the point of incidence, this is the point of incidence. You have learned this in reflection also. So, if I draw a normal at the point of incidence, what will happen? The light ray, instead of traveling along its main path, will get deviated. Original path, it will get deviated and it will bend towards the normal. It will bend towards the normal. So, this is the new direction of light. Okay. So, what happens here? The light changes its path or direction. So this is the concept of refraction. Okay. So what happens here, when light moves from rarer to denser medium, it definitely bends towards the normal. This light ray marked with red color is the incident ray, and the light ray marked with green color is the refracted ray. So if I consider the angle between the incident ray and the normal, this is the angle of this is the angle of incidence. This is the angle of incidence. Okay. So can denote it as I, letter I, and this angle made between the refracted and the normal can be regarded as the angle of refraction by the letter R. Okay. So when light actually travels from rarer to denser medium, what happens? The angle I, angle of incidence, is greater than the angle of refraction. So here angle of incidence I is actually greater than the angle of refraction R. Okay. Now coming to the second case. What will be the second case? Just consider the opposite case, that light is moving from a denser to rarer medium. Okay, light is moving from a denser to rarer medium. So this is the surface separating the two medium. The incident light falls on the surface separating the two medium. Had there been same medium, it would not have traveled along the same path. It would have not deviated from the original path. It would travel along that red line. But as the medium has changed, so first of all let us draw the normal at the point of incidence. So this is the normal at the point of incidence. In this case, what will happen? The light ray will bend away from the normal. Bend away from the normal. The figure will be something like this. Okay. Let's wait a little bit. I have not mentioned the mediums here. So this is the angle I. This is angle R here. Fine. This is say considered a denser medium. Say this is glass. So glass is a denser medium in comparison to say water. Water is a rarer medium. So light is moving from denser to rarer medium. Okay. Now in this case, what happens? As the speed of light increases, the light bends away from the normal and moves around the path denoted by the green color. Okay. So in this case, what happens? The angle of incidence is less than the angle of refraction. Okay. So this is the case here. So you can see that in both these cases, what happens? Light actually deviates from its normal path, and this deviation is actually caused due to the change in the speed of light. In this case, the speed of light has decreased as it enters a denser medium. In this case, the speed of light increases as it has entered a rarer medium. Okay. So due to this change in speed, what happens? The path of the light is changed, and this change in the path of the light is called refraction. So can you now define refraction? Obviously you can define. So you may note it down also. It is also given in the books. You can also read it from there. I am just repeating it so that you can understand the concept. So you can define refraction like this, that when light travels from one transparent medium to another transparent medium having different densities, or rather you can say having different optical densities, then light bends from it or deviates from its normal path or original path. This deviation of light is actually called refraction. So I think the concept of refraction is clear. And why does this refraction takes place? This refraction takes place because change in speed of light. Refraction takes place because change in speed of light. Change in speed of light. Remember this point. Refraction is taking place due to change in speed of light. If the speed of light in both the mediums are same, consider such a situation where there are two different transparent mediums, but the speed of light is same in both the media, then no refraction will take place. This is a condition that light is traveling from one transparent medium to another transparent medium, both are different, but speed of light if remains same, then no refraction will take place. Okay, fine. So I think the concept of refraction is clear. Now let us move on to the case where the light can fall normally or perpendicularly to the surface separating two media. Then what happens? Can you imagine? Okay. Let us draw the case what it is happening. Then it will be easier for you to understand. If the light actually falls normally or perpendicularly at the surface separating the two media, consider that this is the surface separating two medium or two media. The incident ray is falling on perpendicularly, exactly perpendicularly. So at 90 degree to the surface. In this case, what happens? The refracted ray or the refracted ray will travel at the same way as the incident ray was coming. So there will be no refraction. So this is the case when angle of incidence is actually 0 degree. In that case, what happens? The angle of refraction is also 0 degree in the other medium. So this is a case when no refraction of light takes place, although these two mediums are separate. Say this is medium 1 and this is medium 2. Both are different medium, not the same. So both are different medium, but still no refraction takes place as the incident light is falling perpendicularly. I think you have remembered also in case of reflection, something similar thing happened when a light falls on a surface, opaque surface perpendicularly. It is reflected back along the same path along which it was coming. So this is one condition when no refraction will take place, although light is traveling from one transparent medium to another transparent medium. Okay, so just if we just note down the conditions for no refraction. So just noting it down, conditions for no refraction. You can write it like this: although light is traveling from one medium to another medium. Okay, although light is traveling from one transparent to another transparent medium, traveling from one transparent to another transparent medium. Okay, but still no refraction takes place. So what are the conditions? First of all, the incident light falls normally on the surface, and that is here you can say the angle of incidence is equal to 0. This is the condition. And the second case is that when the speed of light remains same in both the medium. So speed of light remains same in both the medium. Remains same in both the medium. Both medium. So media is actually the plural form of medium. So speed of light remains same in both the medium. So these are the two conditions when no refraction will take place. Okay. So these are the basic concepts of refraction. Today we will be ending our class here. In the next class we will be discussing about the laws of refraction, and I have already mentioned that why refraction is taking place due to the change in speed of light. So I think in the next video we will be continuing from here. Today time is not permitting us. So till the next video I will be saying you goodbye. Take care, please study well, and if you have any query please do mention in the comment box. Thank you.